In real world scenarios, certain quantities cannot be negative and must be within a specific range. Absolute inequalities allow us to express these constraints mathematically, making them essential for modeling practical situations. Hello math learners, Hassan here. Today we are diving headfirst into absolute value inequalities. Okay, so let's start. An absolute value inequality is an inequality that contains an absolute value expression. For example, if you have absolute value of x less than 2 and absolute value of x greater than 2, these are absolute value inequalities because these two inequalities contains an absolute value expression. Previously, we learned that absolute value of x is equal to 2 means the distance between x and 0 is 2. This x can be written as x minus 0 equals 2. And if you want to graph it on a number line, we can see that here is the 0 and we have 2 on the either side. Now we'll just replace this equal sign with the inequality sign and solve the x variable. The inequality absolute value of x less than 2 means the distance between x and 0 is less than 2. So if you want to graph it on a number line, we can see that we have negative 2 over here and we have positive 2 over here. We find the overlapping region to indicate this less than 2 section. So we can write this as x greater than negative 2 and this one x less than 2. And it looks familiar, right? This one is an example of compound inequality with AND relationship. We can see that we have this overlapping region and we have this minimum value and we have this maximum value. So the graph bounded by this minimum and maximum value is the example of compound inequality with AND relationship. Now we'll see the inequality with absolute value of x greater than 2. This means the distance between x and 0 is greater than 2. You can see that this distance is less than 2 and this portion is greater than 2. So this one is an example of compound inequality with OR relationship. Now we'll see the strategies to solve absolute value inequality. The first one is we know that the absolute value inequality is a representation of compound inequality with AND or OR relationship. So we'll just write the compound inequality from the absolute value inequality. And how do you write that? So if we have absolute value inequality with less than a value, we use AND relationship. And if it's an AND relationship, we know that we have x greater than the negative value and x less than the positive value. Meaning, let's say over here we have this negative c and over here we have this positive c. Because the intersection is this overlapping region, so it has to be x greater than negative c and x less than positive c. So that's what we'll do for this AND relationship. And this is what we have when the absolute value of x is less than a constant or any number. For the second case, if the absolute value of inequality is greater than a number, we use OR relationship. For this OR relationship, the right value will go all the way to the right and the left value will go all the way to the left. So in this case, we just take this x less than negative c, and for this we take x greater than positive c. So you can see that we just write these two inequalities and then solve these two inequalities. So the second step is we solve both inequalities. Once we solve, then we grab the inequality if required or asked in the problem. Now let's try to solve this problem over here. We have absolute value of x plus 7 less than or equal to 2. Now we know that this is the less than or equal to inequality, so we'll apply AND relationship. So first we'll take x plus 7 greater than or equal to negative value and x plus 7 less than or equal to positive value. Remember, for the n inequality, we just take the greater than or equal to negative value and less than or equal to positive value, and then we solve these inequalities. For the left one, we just subtract 7 on both sides, and for this right one, we also subtract 7 on both sides, and then we get x greater than or equal to -9, and for this one we get x less than or equal to -5. Now if you want to graph it on a number line, we can see that we have -9 over here on the number line and -5 is somewhere here. In both cases we have a closed circle, so just make the circle closed, and since this is an and relationship, this would be the overlapping region. So this is our solution over here. Now we'll try to solve this inequality. It says the absolute quantity of 8x minus 11 is less than 0. Now we know from the properties of absolute value equation that the absolute value cannot be less than 0. So in this case, by definition, the absolute value of an expression must be greater than or equal to 0. The expression absolute value of 8x minus 11 cannot be less than 0. So we cannot have any solution over here. So remember this property of the inequality. We need to have any absolute value inequality to be greater than or equal to 0 in order to solve the variable. Again, a quick recap on how we are solving these absolute value inequalities. So we need to write this compound inequality from the absolute inequality. Again, a quick recap on how we are solving these absolute inequalities. So if we have this absolute value isolated and we have this less than symbol, we use and relationship. And if we have absolute value with greater than symbol, we use or relationship. First, we make sure that we have this absolute value in isolated form, and then we check whether we have a less than symbol or a greater than symbol. If you have a less than symbol, we use and relationship. If you have a greater than symbol, we use or relationship. So for and, we use this overlapping region. For or, we use the non-overlapping region. Now technically this value is -c and this value is +c, since this is on the right side, this is +c and this is -c. Since this region is greater than -c, so we have x greater than -c, and this region is less than +c, we have x less than +c. For the or part, we have this region which is x less than -c, and for this part we have x greater than +c. Now let's try number 1. We have 10 absolute value of 5p plus 4 less than 40. First, we make sure that we isolate this absolute value quantity. So we divide both sides by 10. So if we divide both sides by 10, we get absolute value of 5p plus 4 less than 4. And you can see that we have a less than symbol, so this is and relationship. So we use x greater than -c and x less than +c. So we just rewrite this into two inequalities. The first one is this absolute value 5p plus 4 greater than negative value of this c. So we have negative value of this 4, and since this is and inequality, we have 5p plus 4 less than positive value, so we have 4. Now let's try to solve it. To solve, we just take this 4 to the right side, we subtract 4, we have 5p greater than -8, and for this one we subtract 4, we get 5p less than 0. To find p, we divide both sides by 5. So here we divide this by 5, and we divide this by 5. So we have p greater than -8 over 5. And for this one, to find p, we divide both sides by 5 here as well. We get p less than 0. Since we know that this is an AND inequality, there is an overlapping region, we can rewrite these as a single inequality. So here, now that we have solved these two inequalities, we can rewrite this as a single inequality. To rewrite this as a single inequality, I need to reverse the one with the lowest value. Here we have -8 over 5, and here we have 0. We know that -8 over 5 is the lowest value, so we just reverse this one. So to reverse this, we just swap the sides. So p greater than -8 over 5, we just reverse this as -8 over 5 less than p, and this one is p less than 0. We can just keep this p at the center, and we have -8 over 5 less than p less than 0. Remember, this inequality is exactly same as this and exactly same as this. If we split it up, we see that we have -8 over 5 less than p, and we have p less than 0. Now let's try to work on number 2 here. Here we see that we have absolute value of 2x minus 4 divided by 3 greater than or equal to 5. So first we need to isolate this absolute value quantity. Now this absolute value quantity and 3 are related by a division sign. So we need to multiply by 3 on both sides. If I multiply by 3 on both sides, you can see that we have absolute value of 2x minus 4 greater than or equal to 15. Now that we see that we have a greater than symbol, we use OR relationship. So we have this 15 right here, and we need to use this relationship. So just rewrite these with two inequalities: 2x minus 4 less than or equal to -15, or 2x minus 4 greater than or equal to +15. So now that we have split it up, we'll just solve this variable x. So let's see how we can solve it. So we have this 4 right here. We just add 4 on both sides. If we add 4 on both sides, we have 2x less than or equal to -15 plus 4, that is -11. Divide by 2, we get x less than or equal to -11 over 2. For this one, again, we can add 4 on both sides. If we add 4, we get 2x. Here we add 15 and 4. We get 19. Divide both sides by 2. We get x greater than or equal to 19 over 2. Since these two inequalities are represented by OR inequalities, so there would not be any overlapping region, so you cannot rewrite this as a single inequality. So that's our answer. Problem number 3 says the absolute quantity of 7 plus 10v plus 3 less than or equal to 6. Now here again we see that we have an absolute inequality. The first step, we make sure that we isolate these absolute value quantity before we apply these two rules, because sometimes signs can change when we isolate these absolute value quantity, and we'll see that in a problem solving part. So first we make sure that we isolate this absolute value quantity. Now to isolate this absolute quantity, I just need to get rid of this 3. So we subtract 3 from both sides. And now we have absolute value of 7 plus 10v less than or equal to 3. Now we apply the AND or relationship. Here you can see that we have a less than or equal to symbol, so we use this relationship, which is AND relationship. So we have this 7 plus 10v, and we write greater than or equal to, since we have an equal sign, the negative value of this quantity, which is -3, and 7 plus 10v less than or equal to the positive value of this quantity, which is +3. Now we solve for this variable v. So first we take this 7 to the other side. We subtract 7, since this is a positive 7. By subtracting 7, we get 10v greater than or equal to -3 minus 7, that is -10. And then we divide both sides by 10. We get v greater than or equal to -1. For this part, we have 7 plus 10v less than or equal to 3. So we take 7 from the left side, we subtract 7. We get 10v less than or equal to 3 minus 7, that is -4. Divide both sides by 10. We get v less than or equal to -4 over 10. We can simplify this as a fraction. So divide both by 2. We get 2 here. If we divide 10 by 2, we get 5 here. So it's -2 over 5. Now we see that these two inequalities are represented by AND inequality. So you can rewrite this as a single inequality. So the quick strategy is minimum value less than or equal to variable, which is v, less than or equal to maximum value. So this is a quick shortcut that we can apply. So we have to see which one is the lowest value here, -1 or -2 over 5. Definitely -1. So we write this -1 right here, less than or equal to v, less than or equal to -2 over 5. We see that both of these inequalities have an equal sign underneath, so we are using equal sign. Now let's see how you can solve number 4. For number 4, we see that we have a -6, then absolute value quantity of -7 plus 2x, then we have less than symbol, we have -30. Now by looking at this less than symbol, we can assume that this is an AND relationship. But wait a minute, we see that this absolute value quantity is not in isolated form. So we need to isolate this. To isolate this, we need to get rid of this -6. So we divide both by -6 first. If we divide both by -6, we see that we have this absolute value quantity of -7 plus 2x. Now that we have divided both by a negative number, this inequality symbol would reverse. So we have greater than -30 divided by -6, that is +5. So you see that sometimes a problem can give you an inequality symbol which can change by isolating the absolute quantity part. Now we check whether we use AND or OR relationship. We see that we have this absolute value quantity greater than a constant. So we have this OR relationship here. So for OR relationship, we write x less than negative quantity of the value. So we have this -7 plus 2x less than negative quantity of this value, which is -5, or -7 plus 2x greater than positive quantity of this value, which is positive 5. So now we isolate the variable x. First we add 7 on both sides, and we have 2x less than negative 5 plus 7, that is positive 2. We divide both by 2, we get x less than 1, or we add 7 on both sides. Here we get 2x greater than 5 plus 7, that is 12. Divide both by 2, we get x greater than 12 by 2, that is 6. Now these two inequalities are represented by OR relationships. We cannot combine these as a single inequality. So just keep these as our answer. So this is how we solve absolute value inequalities. Let's look at this number 5 here. We have absolute value quantity of 4n minus 6 minus 3 greater than or equal to 43. Now again, the first task is to isolate this absolute value quantity and then apply this relationship. So first we add 3 on both sides. If we add 3 on both sides, we get absolute value quantity of 4n minus 6 greater than or equal to 43 plus 3, that is 46. Now we see that we have a greater than or equal to symbol, which is this OR relationship. So we write this relationship, which is this absolute value quantity less than negative value of this constant, or absolute value quantity greater than positive value of this constant. So we have this 4n minus 6 less than or equal to, because we have an equal sign, negative value here, which is negative 46, or 4n minus 6 greater than or equal to positive value of this constant, which is 46. Now just solve for this variable. So here we just add 6 on both sides. If we add 6 on both sides, we get 4n less than or equal to negative 46 plus 6, that is negative 40. We divide both sides by 4. We get n less than or equal to negative 10. Or we have this inequality right here. Add 6 on both sides. Adding 6, we get 4n greater than or equal to 46 plus 6, that is 52. We divide both by 4. We get n greater than or equal to 13. Now again, we see that these two inequalities are related by OR inequality, so you cannot combine this as a single inequality. So that's our answer. Now let's try number 6 here. In this problem, again, we see that there is a greater than symbol. So we may assume that this is an OR relationship, but wait a minute, we see that this absolute value quantity is not in isolated form. So to isolate this, I need to divide both by negative 10. When I divide by negative 10, I have this absolute value quantity in isolated form. But now that we divided by a negative number, so this inequality symbol will be reversed. So we have a less than symbol. Negative 70 divided by negative 10, that is positive 7. Now we see that we have a less than symbol. We use this AND relationship here. So we just write negative 9m minus 2. For AND relationship, we have greater than the negative value of this constant, -7, and -9m minus 2 less than positive value of this constant, which is +7. Now we just need to solve for this variable m. Here we just add 2 on both sides. If we add 2 on both sides, we get -9m greater than -5. Divide both by negative number. We divide both by -9, we get m. Since we are dividing by a negative number, this would be less than 5/9. And here we have -9m minus 2 less than 7. Add 2 on both sides. Adding 2, we get -9m less than 7 plus 2, that is 9. We divide both by -9. We get m greater than -1. Since you divided by a negative number, we reverse this inequality symbol. Now we see that these two inequality expressions are related by AND relationship, so we can combine these into a single inequality. So let's see how we can combine this into a single inequality. So the formula or the trick here is, let's try problem number 7 here. So we have absolute value quantity of -4 minus 2b plus 10 less than or equal to 30. Again, the first step is we isolate this absolute value quantity. So in this case, we subtract both sides by 10. If we subtract, we have this absolute value quantity of -4 minus 2b less than or equal to 30 minus 10, that is 20. Now we see that we have these absolute value quantity less than the constant value, so we use AND relationship. In this case, we use this formula right here. So -4 minus 2b greater than the negative value of the constant, which is -20, and -4 minus 2b less than the positive value of this quantity, which is +20. Now we solve for this variable b. So first we add 4 on both sides. Adding 4, we get -2b greater than -20 plus 4, that is -16. Now to get the b isolated, we divide by -2. We have b. Since we are dividing by a negative number, we need to reverse this inequality symbol. B less than -16 over -2, that is +8. And here we are adding 4 on both sides. We have -2b less than 20 plus 4, that is 24. Divide both sides by -2. We get b greater than, since we are dividing by a negative number, so we need to reverse this inequality symbol. 24 by -2, that is -12. Now again, these two inequality expressions are related by AND relationship, so we can use this shortcut trick. Minimum value less than variable, in this case the variable is b, less than maximum value. So 8 and -12, the minimum value is -12 less than b, which is right here, less than b, less than the maximum value is 8. So you can see that these two inequalities can be written as a single inequality. Now let's look at number 8. Number 8, we have -5 times absolute value quantity of 5k minus 7 greater than or equal to 10. Again, we may assume that this is an OR relationship since we have a greater than or equal to symbol here. We need to make sure that we isolate this absolute value quantity first, and then we check whether we have to use AND or OR relationship. So first we divide both by -5. When you divide by a negative number, we see that we have this absolute value quantity of 5k minus 7 less than or equal to -2. Since we are dividing by a negative number, this inequality sign would reverse, which means we need to use AND relationship. So here we see that we have an absolute value of this expression less than or equal to -2. By definition, the absolute value of an expression must be greater than or equal to 0. So this absolute value expression of 5k minus 7 cannot be less than 0. So in this case, we cannot have any solution. So the answer is no solution, because absolute value means the distance must be greater than or equal to 0. Okay, now let's look at number 9. Here we have absolute value of 7 minus 8n plus 4 less than -37. So first thing first is we have to isolate these absolute value quantity. So we subtract both sides by 4. Absolute value of 7 minus 8n less than -41. Earlier, we have learned about the properties of absolute value. The absolute value of an expression must be greater than or equal to 0. So in this case, this one cannot be less than -41. So again, we have no solution. Let's look at number 10 here. We have absolute value of 2 minus 6x plus 7 greater than or equal to -39. So first we isolate these absolute value quantity, and we do this by subtracting 7 from both sides. If you subtract 7, we get absolute value quantity of 2 minus 6x greater than or equal to -39 minus 7, that is -46. Now here we see that the absolute value quantity of 2 minus 6x is greater than or equal to -46. Now from these properties of absolute value, we see that this must be greater than or equal to 0. So from these properties, we see that 2 minus 6x greater than or equal to 0. Now this greater than or equal to 0 is always greater than or equal to -46. So whatever expression is greater than or equal to 0 is always greater than or equal to -46. So this is true for all real numbers. So try to see the difference between number 9 and number 10. Here in number 9, we have this absolute value quantity less than a negative number, which cannot be true because we cannot have any absolute value less than a negative number. So we have no solution. But here we have this absolute value greater than or equal to a negative number, which is always true for all real numbers because all real numbers will satisfy this first property of absolute value, which is greater than or equal to 0. So any number which is greater than or equal to 0 must be greater than or equal to -46. So that's why for number 10, we have all real numbers as the solution. Understanding absolute inequalities lays the foundation for more advanced mathematical concepts. Keep practicing this topic. Alright, that's it for this video, and I'll see you in the next one. Now, let's get to study.